In clinical work, there is a big problem and there's an opportunity. The problem relates to intravenous catheters. Intravenous catheters often suffer from complications such as infection or thrombosis. Now, what happens if a catheter suffers from that complication is that you have to remove it. But oftentimes, the vessel in which it was placed is damaged. And sometimes the vessel doesn't recover, and you can never use the vessel again for the purpose of a catheter. There's also an opportunity. That opportunity is microbubbles. Microbubbles are currently primarily used for diagnostic work, but we can load them with medicine to combat infection with antibiotics or combat thrombosis. My name is Martijn Verhagen. I'm a pediatric radiologist at the radiology department of the UMCG. And to try and combat this problem and this issue, I'm working together with my colleague Patrick van Rijn.
I'm Patrick van Rijn. I'm from the Department of Biomaterials and Biomedical Technology here at the UMCG. And we are actually investigating together with PolyVation and Bether Encapsulates to see whether we can bring these microbubbles to the surface of a catheter and load these with antibiotics. And thereby, with ultrasound, we can pop these bubbles and thereby we can combat the infection. And that means that we don't have to remove the catheter, thereby we retain a better healthy vessels, and then Martijn does not have to redo it again. We do this in line of the iMPaCT implant, and we lead Tramline as a project within that supported by the SNN.
This is an experiment to illustrate what microbubbles are. So we use this well plate and we just did the experiment, and this is the clip we stored just to demonstrate. So on the left well, you see all of these little speckles. Those are the microbubbles we can actually see reverberating with the ultrasound. And on the right, there is a reference well just filled with water. So if you press play, we can see that all those speckles, they start popping, they start disappearing when we increase the energy we apply to them. So you see them just disappearing. And then if I move my probe a little bit, you can see some new microbubbles, and there they go again. So we can control when we pop them, we can control when we release whatever we've put inside of them. So that's the power of those microbubbles, and that's what we aim to use in this project.
As Martijn showed the concept of bubbles in solution and how you can image but also pop them, of course it is crucial not to have them in solution, but in Tramline we want to have them on the surface of the catheter. Thereby we use polymers also developed by PolyVation and the capsules, the bubbles developed by Bether Encapsulates. The aim overall is to use the hydrogel coating on the surface of the catheter, and embedded are the bubbles that we can visualize and pop using medical ultrasound via the same concept as that Martijn just showed. While we pop them, the drugs encapsulated will diffuse out, and thereby it will kill the infection on the catheter. And since these polymers and capsules are developed by PolyVation and Bether Encapsulates, companies that are hosted and located in the north of the Netherlands, this will give a tremendous impact in the working environment and medtech development in the north of the Netherlands.
The clinical impact of this project when we are successful will be highly significant. Of course, currently we focus on the intravenous catheters, but the technology behind it we can apply to many other implantable devices. Every hospital, every patient that has to do with implants like this will benefit. It will put us on the map, and we are very much looking forward to starting this project.